അപ്പോൾ നെക്സ്റ്റ് നമുക്ക് നോക്കാനുള്ളത് iterative methods for solving equations of the second kind ആണ്. അതായത് this second kind equations of the second kind, this form will be can be solved by the method of successive approximations. This approximation method will discuss, and here uh, this y of x is obtained from by f of x plus lambda integral a to b k of xi plus y of psi. This y of psi is we denote this as initial approximation y naught, and then after this computation we will get this y of x. We denote this by y1 of x, first approximation. So by iteration formula, by successive approximation, you can also deduce this formula: yn of x is equal to fx plus lambda integral a to b k of xi yn minus 1 of psi. And this b is replaced by x, we will get equation for Volta type. This is same for Volta type also. So what will we get for first iteration? We first obtain the result by replacing the y in the right hand side of 163. This yes, this is the fundamental equation, and this right hand side by replacing y in the right hand side member by y1, and in the substitution we replace the current variable x in 164 by the dummy variable psi, and is to replace psi in dummy variable, we replace it by another dummy variable psi 1. അപ്പോൾ ഇത് എന്തിനാ അങ്ങനെ ചെയ്തതെന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ ദിസ് നമ്മൾ ഒരു മിനിറ്റ്, യെസ്, നമ്മൾ തുടക്കത്തിൽ നമുക്കൊരു ഇനീഷ്യൽ അപ്രോക്സിമേഷൻ ഉണ്ട് y നോട്ട് എന്ന് പറഞ്ഞിട്ട്. എന്നിട്ട് നമ്മൾ y1 കണ്ടെത്തും ഈ ഫോർമുല ഉപയോഗിച്ചിട്ട്. എന്നിട്ട് ഈ y1 എടുത്ത് നമ്മൾ y2 കൊടുക്കും. y2 കൊടുക്കുമ്പോൾ y2ൻ്റെ എക്സ്പ്രഷൻ എന്ന് പറയുന്നത് ദിസ് ഫ്രം ഹിയർ y2 ഈസ് ഈക്വൽ ടു fx plus lambda integral k into y1 of psi. y1 of psi is used. So y1 of x we have computed here. So we replace x by psi. So f of psi will be here, and here also psi. Here also psi appears. So x and psi are independent variables and they are not related. So we replace this psi by another variable psi1, and this is also psi1 d psi1. Then only this x and psi varies over all the values between a and b. If we do not replace, then the kernel will only take values psi comma psi, that is identical values only they are kernel is taking. By replacing this, the kernel takes all the values psi and psi1 from the interval a to b. 1 minute. Okay, so we replace this x by psi and this psi by psi1, and uh, we will substitute this yes, lambda k y1 in the place of integral k y1. We will place this one, and we will get this one. So what will we get? This arranging this one is f of x and lambda k of xi into f of x plus k into two integrals will come. This is the main integral, and inside this the second integral comes here. So this is the arrangement. This can be iterated to any steps y2 etc., keeping in mind that the variables must be replaced in each step. That here now we will replace x by psi and psi by psi1, and we will introduce in place of psi1 psi2 because of the earlier reason that we have noted here. So same reason appears here. So what will you get on y3? If you compute like this, we will end up in this equation. So For simplification of this large equation, we will introduce an integral operator script k. This denoted by script k of f of x is identical equal to integral over a to b kernel into this small f. So what is this? The integral equation 163. We have the main integral equation. What will be the form of this one? We know that integral a to b k of x y is equal to script k. This script k of here y of zeta. Script k y. So what will we get? We will get as that equation as f of x plus lambda script k y. So yn of x will be 165. If we look on the 165, we will get f of x plus lambda k raised to y raised to n minus 1. So the equations by the introducing the new operator, uh, we will modify the equation 164, 166 and 167. What is 164? This yes, it will be earlier y1 is equal to you just note that it is f of x plus lambda integral a to b this k into this y of d psi. ഇതായിരുന്നു 164. അതുപോലെ നമ്മൾ ഇൻ്റഗ്രൽ കെ വൈ എന്നുള്ളത് നമ്മൾ ഈ ഫോർമാറ്റിലേക്ക് കെ വൈ നോട്ട് കെ വൈ നോട്ട് എന്നുള്ളത് ഈ ഫോർമാറ്റിലേക്ക് മാറി. അപ്പോൾ y2 എങ്ങനെ ചേഞ്ച് ചെയ്യും? എഫ് ഓഫ് എക്സ് പ്ലസ് y2 എന്ന് പറയുമ്പോൾ ദാണ്ട് ഇവിടെ ദിസ് വൺ ഇത് നമ്മൾ സ്ക്രിപ്റ്റ് കെ ക്യാപിറ്റൽ എഫ് എന്ന് വരും. ഇവിടെ എന്ത് വരും? ഇവിടെ സ്ക്രിപ്റ്റ് കെ വൈ നോട്ട് വരും. അതായത് ഇവിടെ ലാംഡ സ്ക്വയർ ഇൻറ്റു ഇൻ്റഗ്രൽ ക്യാപിറ്റൽ കെ സ്ക്രിപ്റ്റ് കെ വൈ നോട്ട് എന്ന് വരും. ഇതെന്ന് പറഞ്ഞാൽ എന്താണ്? സ്ക്രിപ്റ്റ് കെ ഇൻറ്റു script k of script k y naught, that is script k square y naught. What will we get? The script k square y naught lambda square. Likewise, we can modify this y3 as this formula, and more generally we can extend it as f of x plus lambda script k of capital F of x lambda square script k square of capital F of x, etc. The last term will be script k raised to n minus 1 of this last term will be yes, last term will be script lambda raised to n script k n of y naught of x. Other terms are all of capital F of x. So this we denote the last term as Rn of x, the remainder, and we proceedingly we will as n tends to infinity, we will show that this Rn of x tends to 0, and thus this form we will get as so many iteration. After so many iteration, it will this yn of x will converge to y of x, and the right hand side will be capital F of x plus this summations. So it will be n minus 1 lambda raised to n script k n capital F of x plus Rn is there, but as n tends to infinity, Rn goes to 0. So we will not write that. So we will show that this y of x, final iteration y of x will have this form. So by introducing this form, we must assure that this series, infinite series, must converge. So under what condition this infinite series must converge, that we will look. And this kernel and capital F of x are assumed to be continuous for all values of x and psi in AB. We will assume that like that. So their magnitude, by continuity property, their magnitude will be bounded in this open AB, that is capital K is bounded by some capital M, and capital F is bounded by small m in AB. Also the magnitude, we assume that, we suppose that the magnitude of the initial approximation y naught is bounded in AB, so y naught will be less than or equal to C. So what will we get? We will look upon the modulus value of script k of y naught. What is y naught? Script k of y naught, that is integral a to b by definition capital K into y naught of psi. This will be less than or equal to integral a to b mod k of mod k into mod y naught. What is mod k? Mod k is less than capital M, so this will be less than or equal to integral a to b capital M. This y naught will be less than c, so mc integral m and c are constants. Taking outside, what will we get? Mc into integral a to b d psi, that is integrating this factor is b minus a. So what we will end up in this formula. Likewise, so k2, script k2 of y naught is script k of y naught. That is script k of y naught is integral a to b k into y naught. That is then again script k is applied. What will we get? Modulus of integral large integral main integral a to b script small k kernel into integral inside integral this formula. What will we get? The whole modulus is will be less than or equal to integral a to b the integrand modulus. So the integrand is k into this integral, so we can the modulus value splits into mod of kernel into mod of integral. This mode of integral we have already calculated here, so it will be less than m into b minus a into c. So we can write this one follows that, and for this one we can write by this formula m into b minus a into c d psi. So this kernel is less than or equal to capital M. This is m into b minus a into integral a to b d psi. This constant can be taken out, and one b minus a will additionally come into action. So we will get m square into b minus a into this b minus a square c. That is k2 script k2 will be less than or equal to m square b minus a c. So likewise by induction we can prove that kn of y naught will be less than or equal to m and b minus a raised to n c. Likewise, similarly, kn f of x will be m and b minus a. This capital F of x is less than or equal to small m. So by replacing this c by capital M, we will get this equation. So this Rn of x, what is the formula for Rn of x? Rn of x have this formula. So modulus of Rn of x will be modulus of lambda raised to n script kn modulus. What is script kn modulus? But we have already calculated script kn modulus as this one. So what will we get? This Rn will be less than or equal to lambda raised to n into this one. So mn b minus a raised to n c. And if for increasing n, and if mod lambda less than 1 by m into b minus a means implies if we take this condition, we will end up into mod lambda m into b minus a will be less than 1. So we will take yes, m is positive, b minus a is positive. So modulus, if we insert modulus, and there is and also no modulus will not change the change our inclusions or inequalities. So what will we get? We will get taking some smaller is equal to lambda m into b minus a, and we will get here small r will be less than 1. So we will end here as mod Rn of x will be less than or equal to small r raised to n into c. As n tends to infinity and r less than 1 implies r raised to n goes to 0. You know that. So as n tends to infinity, this factor goes to 0. This modulus is less than or equal to, so we will get 0 less than or equal to mod Rn of x less than or equal to 0. So this will, by Squeeze theorem, this will also goes to 0. So if this condition prevails, we will get that Rn of x tends to 0. So what will we get? Okay, 1 minute. So when this condition prevails, we have this remainder goes to 0. Also, we have to check whether this series converges or diverges also. So for this we pick up the series mod f of x plus summation this one. This will be less than or equal to mod f will be less than or equal to m plus summation and this modulus lambda raised to n. This kn f of x will be less than or equal to m n b minus a raised to n. So we will end up in this formula. So by checking this, we will get, so this series is dominated by this series, and this summation, if we check, we will know that this is a geometric series with the factor, multiplying factor, this r is equal to mod lambda m into b minus a. ഈ ഫാക്ടർ വെച്ചിട്ടാണ് എല്ലാ ടേമുകളും മൾട്ടിപ്ലൈ ചെയ്ത് പോകുന്നത്. സോ നമുക്കറിയാം ജോമെട്രിക് സീരീസിന്റെ മൾട്ടിപ്ലൈ ചെയ്യുന്ന മൾട്ടിപ്ലൈങ് ഫാക്ടർ ഈസ് ലെസ് ദാൻ 1 ആണെങ്കിൽ ഇത് കൺവേർട്ട് ചെയ്യും നമുക്കറിയാം. ദാറ്റ് ഈസ് ദിസ് ഈസ് ലെസ് ദാൻ 1 മീൻസ് മോഡ് ലാംഡ ലെസ് ദാൻ 1 ബൈ എം ഇൻറ്റു ബി മൈനസ് എ. ഇത് തന്നെയാണ് നമ്മൾ നേരത്തെ എടുത്ത ഈ കണ്ടീഷനും. ഈ കണ്ടീഷൻ ഓൾറെഡി ഇവിടെ പ്രിവെയിൽ ചെയ്യുന്നുണ്ട്. So we can say that this geometric series converges, thereby this series is dominated by some converging series. So this series also converges by results in series theory and series and sequences. So this geometric series that is written here converges. Absolute convergence is also, we have taken the modulus value, and uniformly convergence also this. Uh, so this y is equal to this one forms a solution to our integral equation, and all the terms, other terms are defined. It is written here, and yes, in Fredholm equation we have discussed. In Volta equation also, the only difference is this b is replaced by this x and all other terms, and the integral operator here is defined by script k x, and all other concepts are same. You can easily check, and this modulus of kx y naught will be this one, and will be less than or equal to k is less than capital M, and this y naught is less than capital C, and we will the rest is integral a to x. Integral a to x is x minus a. So next kx to 2 of y naught will be this one, and yes, this one as similar to earlier step, we will end up here. So k2 at y naught will be less than or equal to mod k of xi into this modulus of k1. This modulus of k1 is less than mc into psi minus a, we have calculated. We will replace here we have denoted x, so we will replace this x by psi d psi. So what will we get? This mod k is less than or equal to m, so m into m square is here, this c is here, so integral a to x psi minus a d psi. What is integral a to x psi minus a dx? D psi is equal to psi square by 2, from a to x limit is given, and minus a psi a into psi. This a to x is, we evaluate this one, and we take this 2 as the whole divisor. We will get x minus a the whole square. So m square, we will end up in this m square. This is x minus a the whole square, we have denoted here by 2, by 2 into 1 into this c. So likewise by iteration we can denote this as here it is script k x2. So here it is Rn and lambda n, mod lambda n, script kx raised to n of y naught. Here it is 2 of y naught. We will end up in this in similar formula, m raised to n x minus a the whole raised to n c by n factorial into lambda raised mod lambda raised to c. That is it will be the, we know that x minus a is less than or equal to b minus a, since a less than or equal to x less than or equal to b. So is the x minus a can be replaced by b minus a, this we will get. So this in a similar way as earlier we have found this less than or equal to this one, and this series tends to n 0 as n tends to infinity, and the same similar results follow, converges under this condition. This condition will be less than or equal to mod lambda will be less than or equal to this this 1 minute. So here the difference is that here we have the n factorial on denominator. So as n tends to infinity, this whole factor will tends to 0. So Rn of x will tends to 0. There is no need for any condition on mod lambda as we have seen in the previous case. In the previous case, mod lambda will be less than or equal to 1 by m into something b minus a. But here it is not needed because the denominator contains n factorial. So as n tends to infinity, n factorial goes to infinity, so 1 by n factorial goes to 0. So we will end up in there is no condition on lambda. For any finite value the series converges. So this is the main difference of Volterra equation from the previous Fredholm equation, and this also converges uniformly and converges absolutely and uniformly. Okay, this is an example for this, and this is the same example as we have seen in the previous section, the previous part, uh, and we will end up in y of x. At that section, we have f of x here, but we have here a particular value for capital F of x as 1. So, what will we get in this? Yes, here it is. This one. Yes, yes. Here f of x in this problem, f of x is equal to 1. So we can calculate this c1 and c2 by lambda into c1 plus 3 by 2 c2 plus integral 0 to 1 1 dx, integral 0 to 1 x into 1 dx, that is x dx. That is this equation can be computed since the right hand side f of x is given as 1 here. So what will we get? We will get in, that is the explanation that I have given this s 1 minute. This is given as a matrix notation that we have this uh, as 1 minus lambda a into c is equal to b. Yes, 1 minus lambda a into c is equal to this b, where yes. So this system of equation is given in the matrix format, this format. So what will we get? 1 minus lambda a, 1 minute. Yes, 1 minus lambda a c is equal to b beta. So 1 minus lambda is given as here. Here it is the coefficient matrix. But when we collect the coefficients, we will get this one, and to c is equal to c1 c2 is right hand side b1 beta 1 beta 2. What is beta 1 beta 2? Beta 1 is given as integral a to b g1 of x f of x. Here g1 of x is equal to 1 and f of x is equal to 1, and this is the same as integral. This is beta 1, this is beta 2, same one, same thing comes here. So beta 1 is equal to 1 and beta 2 is equal to 1 by 2. So this is this one, and this is in a matrix form, and this when here we have when lambda not equal to plus or minus 2, when lambda not is equal to plus or minus 2, we will have this determinant not equal to 0. Determinant not equal to 0 means there is an inverse for this matrix. So this matrix determinant is not equal to 0. So what will be the inverse? Inverse is you can easily calculate inverse of a 2 by 2 matrix, and its determinant will be, what is the determinant of this matrix? This determinant of this matrix will be AD minus BC. So this inverse is equal to, we can easily calculate, just swap these numbers D A, then give minus sign to C and B, minus C minus B into 1 by determinant delta. This is the inverse. So for 2 by 2 matrix, it is easy to calculate the inverse. It is swapping these diagonal elements and giving my negative numbers to the other diagonal elements and dividing whole by 1 by determinant. So what will we get? We will get is this form into determinant is given here. Determinant is 4 minus lambda square into 4. So what will we get? We will get, this is the inverse. So this can be uh, computed as multiplying both the sides by I minus lambda I inverse. So I minus lambda I inverse into I minus lambda I, this is equal to C. We will get in left hand side, right hand side I minus lambda I inverse into beta. So I minus lambda I C is equal to I minus lambda inverse into beta is equal to I minus lambda inverse is the whole thing into beta is this one. So arranging this one, this is simple computation, you can easily compute. The second page also is a computation. So this is C1 and this is C2. Yes, and y is calculated as lambda plus C1 into s plus f of x. F of x is equal to 1, and we can arrange in this way and end up in this y as this format. This format is same as this one, so the derivation is there. So the operator k script k f of x will be of here, this is kernel into f of psi. What is kernel here? Kernel is this one, and script k of f is equal to this one into capital F is 1. So by integrating, what will you get? Integral 0 to a 1 d psi, this is 1. Integral 0 to 1 minus 3 x psi d psi, that is integral 0 to 1 minus 3x can be taken outside. This psi d psi is equal to minus 3x into psi square by 2 is equal to minus 3, bound from 0 to 1. So minus 3x by 2, that is 3 by 2 minus 3 by 2 x. Likewise, by expanding these two factors, we can calculate the integral. X and constants can be taken outside, then integration only with respect to psi, variable psi. 1 by 4 we will get, this one is equal to this one. So what will we get? This is a general formula, you know, this y of x is equal to this 0 to 1. Yes, this is the general solution we have denoted, and we sorry, this is Volta type. For this Fredholm type we have this final solution. Yes, this is the final solution. We have computed script k raised to n capital F of x. And script k of x, capital F of x, we will denote here as, yes, script k, k raised to n capital F of x. For n is equal to 1, n is equal to 2, n is equal to 3, we will end up in uh, f of x plus lambda into script k f. Script k f is this one, so it arrives here, plus lambda square into script k square f, that is 1 by 4, lambda square into 1 by 4. Likewise, these results comes here. So what will we get? Here it is 1 plus lambda into 1 minus 3 by 2 x. Here we can common out lambda square by 4 from these two factors. What will we get? Lambda square by 4 into this lambda into 1 minus 3 by 2x, multiplying lambda raised to 3, sorry, this lambda square by 4. um, yes, 1 minute. Yes, yes, this, yes, by taking common out lambda square by 4 from these two terms, what will we get? Lambda square by 4 into 1 plus lambda into 1 minus 3 by 2 x. That is what is inside this bracket is same thing that is left here. So by taken common out from these two factors, lambda raised to this 4 by 16. So we will end up in these two terms inside this bracket here. So what will we get? So we can common out 1 plus lambda into 1 minus 3 by 2 x from all these combination of two terms. So what is left? Here it is 1 left. Here it is lambda square by 4 left. Here it is lambda raised to 4 by 16 left. Collect these terms. We can write this one into this one. So we came to know that this is a geometric series with the multiplier r is equal to lambda square by 4. So if this lambda square 4 is less than 1, that is mod lambda, this mod lambda square less than 1, that is mod lambda less than 2, that is when mod lambda less than 2, this geometric series converges. So this y of x has a finite value to the sum. Geometric series first element is a and the multiplier is r, then if it converges to the sum a by 1 minus r, that is here it is 1 is the first term, so 1 by 1 minus lambda r is lambda square by 4. So this is sum this one, and 194 is a power series expansion valid only when mod lambda less than 2, and is solution when replacing this sum by here, we will end up in 1 plus lambda into 1 minus 3 by 2 x divided by 1 minus this one into this one. So it has this small form. This is valid for all values of lambda. Yes, this is identical with 193 equation, and which itself is valid for all values of lambda except so here mod lambda less than 2, we have this solution. So here it is a note that when this multiplier lambda value is greater than our eigenvalue is plus or minus 2. So if it is greater than our eigenvalue, then then this method will not work, and the series would not converge. And this is a note only. There is no proof to study. And this method of successive substitution in case leads to the power series expansion of this ratio valid only when lambda mod lambda is smaller than the magnitude of the smallest characteristic value. Just not only. Next is a Newmann series, and we have 1 minute. We denote this script k of f of x is this one, and script k square is this one, and yes. Uh, yes, what will we get? We will get script k of f is inducted here. So if we uh, includes include this d psi 1 into the interior portion, we will collect the terms of psi 1, the terms including psi 1. So what will we get? Integral a to b k x psi 1 will become here, psi 1 terms will become here. So d psi 1 will come here, and f of psi d psi will be kept outside. So this arrangement, we will get this term under this square bracket, we will denote it as this k2 iterated kernel k2 of xi, that k2 of xi is integral a to b k into xi1 k psi1 psi d psi 1. So equation 197, this has this form: integral k2 of f of x is equal to integral a to b. This term inside square bracket is replaced by capital K2 into f of psi d psi. So by the repeating the same process, we will end up in kn of f of x is integral a to b, kn of xi f of psi. This is and this kn is the nth iterated kernel provided by the iteration formula kn is equal to integral a to b k kn minus 1 of psi 1 psi. So we write for n is equal to 2, 3, 4, etc. This is valid, and when n is equal to 1, this is also valid. So we have also this relation, no proof is needed, just observe simply. And uh, as we have mentioned earlier, if k of psi is bounded by capital M, and then this script kn will be bounded by mn into b minus a n minus 1. We can look it up. This capital K is k1, k1 also. When k2, when what comes to k2, mod k2 of xi will be less than or equal to this what is expansion of k2, this integral a to b small k into uh, this this k2 here it is k2 this form. So modulus will be equal to modulus of here will be less than or equal to integral a to b modulus of k into modulus of k, that is here we have m into m square into integral a to b d psi, that is b minus a. But this is k3. K3 is equal to, by formula it is k into k2. So this k is bounded by m, and this k2 is bounded by m square into b minus a. So by computing this format we will end up in here. So it is k3 is bounded by m raised to 3 into b minus a the whole 2. So as in general case n, it is bounded by this one. So what will we get? Uh, yes, this is our integral equation, and solution of the integral equation with the notation of equation 200. This notation, what will we get? The solution we have already computed as this y of x is equal to capital F of x plus summation lambda raised to n, this script k raised to n of capital F of x in equation 174. 174 takes this form because we have defined this new notation, this one. So kn of capital F will be replaced by this one as capital Kn. 1 minute. Okay. Yes. What is the solution of this integral equation? We have already calculated here. Yes. This sorry, this is Volta type. This is for Fredholm type. The same, but there is a difference. Yes, this one. This Kn we have defined in a new way here. So in that notation, in the new notation, it will become this format. Yes, this Kn of f of x is equal to this format, and yes, this new format will be this one. This one, you know that this one can be, this is n is from 1 to infinity lambda raised to n. So this can be summarized as n is equal to 0 to infinity, and summation can be taken inside this integral. What is when n is equal to 0? N is equal to 0 means lambda raised to 0 into k1. That is lambda raised to 0 into lambda into k1. That is lambda k1. Here it is when n is equal to 1, lambda k1. No change in these two notations. So for simplicity, we will write this what is in this bracket as another function gamma, capital gamma of xi, lambda is equal to this summation n is equal to 0 to infinity. This term inside this term inside this square bracket, we will end up here. What is the expansion? K of xi plus lambda k2 plus lambda square k3. And this format takes the new form f of x plus lambda gamma into f of psi. This gamma is called reciprocal or resolvent kernel associated with the kernel capital K, and the new series 207. This series is called Newmann series. So for this Newmann series 204, this 204, by this one we came to know that it is found that this series converges absolutely when lambda mod lambda less than 1 minus b minus a. നേരത്തെ ചെയ്ത അതേ ഫോർമാറ്റിൽ ചെയ്താൽ മതി. mod lambda less than 1 by m into b minus a വരുമ്പോൾ ഈ സീരീസ് കൺവേർജ് ചെയ്യും. ഇനി നെക്സ്റ്റ് ഗാമ ഈ ഫോമിൽ എഴുതാം. k ഇൻറ്റു ദിസ് വൺ ലാംഡ റൈസ് ടു n, ദിസ് ഫോമിൽ, അതായത് ലാംഡ റൈസ് ടു n ഇൻറ്റു ഈ ഫോർമാറ്റിൽ എഴുതാം. കെ എൻ പ്ലസ് വണ്ണിൻ്റെ എക്സ്പാൻഷൻ ദിസ് വൺ ആണ്. ഇനി യെസ് 207 ദിസ് ഫോമിൽ അഗെയിൻ എഴുതുമ്പോൾ നമുക്ക് 207 ദിസ് ഫോർമാറ്റിൽ കിട്ടും. is k of xi is 1 minute. Yes, this gamma has this form, and this can be written kn plus 1 to kn plus 2 can be replaced by this function, and this is this one, and this lambda is here. But this is summation lambda raised to n capital K into this one. This summation can be keep inside, though, so this will be get integral a to b lambda here capital K into summation. Uh, yes, n is equal to 0 to infinity k n plus 1 psi 1 psi. What is this one? This is gamma of psi 1 psi lambda. So this can be replaced by this one. So this format also tries, and we will change in notation. We change to psi to t. What will we get? This function we will get. It follows that the reservant kernel gamma considered as a function of the two variable x and t and the parameter lambda here is the solution of equation 205. This 205. This the solution of this equation of this form. This is our fundamental integral equation, and the solution is this form. This form is treated as this form, and then f is replaced by the kernel k. Uh, yes, we have this form gamma of xt lambda here, gamma of psi t lambda here, and this place we have k of xt. We will go to this our fundamental integral equation, that is y of x is equal to capital F of x plus lambda capital K into y of x. We can replace gamma in place of this y. What will we get is that the formal equation is uh, yes, this y of x is equal to this capital F of x plus in lambda integral capital K into y. This was our old integral equation. When here we from by this equation we came to know that if y is equal to gamma, then gamma satisfies this integral equation. So gamma is a solution to our fundamental integral equation with one condition: this capital F is replaced by this kernel capital K. So F is replaced by capital K. This solution of our fundamental equation 205, this is 205, is this gamma of xt. This is a special case. So then next is a problem. If a kernel is of this form, what will be k2? By definition, k2 is equal to this capital K into this yes, k2 definition by this k1. K1 is k of psi 1. What is k of psi 1? 1 minus 3. X is replaced by psi, and psi is replaced by psi 1. So k into k1. So this k2 we have defined. By expanding these two factors, we will get 1 minus 3 x square. By integrating from all these factors from 0 to 1, all these factors 0 to 1, we will end up here. Just integrate. Likewise, k3 can be written as k into k2. K2 we know that this one. So k we know that this one. So multiplying this with this factor and integrating, we will end up here. Also, this we came to know that here k3 is equal to 1 by 4 into this one is equal to 1 by 4 into k1, because k1 is this one. This is k1 is this one. So what will we get? We will deduce this formula for n greater than or equal to t 3 by induction. When n is equal to 3, we have this this is true. So n is equal to 3 at the first step. This is true when n greater than or equal to 3, and suppose that it is true for n minus 1, that is kn minus 1 is equal to kn minus 1 n minus 3 divided by 4, what will be kn equation? It is integral 0 to 1 k into kn minus 1. Replace kn minus 1 by kn minus 1 by 4, and we will get this 1 by 4 is taken outside, integral k into kn minus 3. What is k into kn minus 3? It is kn minus 2. So kn is equal to 1 by 4 into kn minus 2. So this relation is reduced. So what is this gamma? Gamma we have defined as k1 plus lambda k2 plus lambda square k3 here. Yes, here. So what will be this form? So it will be k1. K1 we know that it is here 1 minus 3x psi. So no problem. You put this k1 here by lambda into k2. It is also here. Uh, by replacing k3 by k1 by 4, what will we get? This expression we will get as here k1 plus lambda k2 plus lambda square into, by replacing this k3 by k1 by 4, here it is, and lambda cube into k lambda s 2 here 3 lambda cube into k4. This k4 what is? This k4 is k2 by 2. So here it is k2 by 4. 2 not 4. K2 by 4. By taking common out k1 from first term, third term, fifth term, etc., and taking common out lambda and k2 from second term, fourth term, sixth term, we will end up here. So we have this geometric series here and same geometric series here. When mod lambda less than 2, this geometric series converges to this factor, and the k1 we know that this geometric series can be taken out common, and what will be inside k1 plus lambda k2, that is k1 plus lambda k, and we know that what is k1 and k2 values we have computed here and here. So substituting, we will end up in here for mod lambda less than 2. So is uh, yes, same things are given. So this is the end of this section. Okay, thank you.